हेलो। तो आज हम इस थ्योरम्स के जितने भी 6 पार्ट हैं सारे को एक एक करके प्रूव करेंगे। पहले हम लोग फर्स्ट को प्रूव करते हैं। पहला है इफ ए डिवाइड्स बी, इफ ए डिवाइड्स बी implies a divides bc for any integer for any integer c। हम लोग जानते हैं कि a डिवाइड्स b का मतलब क्या है। a डिवाइड्स b का मतलब है a इज डिवाइजर ऑफ b, या फिर उसको ये भी बोल सकते हैं b इज डिविजिबल बाई a, या फिर b इज अ मल्टीपल ऑफ a। इसका मतलब सबका a डिवाइड्स b का मतलब ये सारा है। तो हम लोग जानते हैं जब a डिवाइड बाय द डेफिनेशन ऑफ a डिवाइड्स b, this implies there exists x belongs to integer denoted by z, x belongs to integer such that b is equal to ax. Now we multiply c on both sides. This implies bc is equal to axc. This implies bc is equal to axc because all axc belongs to integer. Now since x and c belongs to z, this implies xc also belongs to z. We say xc is equal to y. Let xc is equal to y. This implies bc is equal to ay. By the definition of divisibility, a divides bc for any integer. Since we take any arbitrary integer c. Now the first part is has been proved. Now we are going to second part. second question. सेकंड क्या कह रहा है? इफ a divides b and b divides c. If a divides b and a divides c, sorry, a divides b and b divides c implies a divides c. इसका प्रूफ हम लोग करने जा रहे हैं। By the definition, since a divides b, this implies there exists x belongs to z such that b is equal to ax. Similarly, as b divides c, this implies there exists y belongs to integer such that c is equal to by. Now we have to show that a divides c. As हम लोग ऊपर देख रहे हैं c is equal to by. We put the value of b from equation first. We put the value of b. This implies c is equal to axy. Since we know that all these elements belongs to integer, this implies if x and y belongs to integer, then their product is also belongs to integer. We say xy is equal to z, and z belongs to set of integers. This implies c is equal to az, and by the definition a divides c. Hence proved if a divides b and b divides c, then a divides c. Now we are going to the third part. Third part क्या कह रहा है? If a divides b, sorry यहाँ पे है a divides c. This is c. If a divides b and a divides c, implies a divides bx plus cy for any integers x and y. ये हम लोग ये बस ये दो के लिए दिया हुआ है. अगर इसमें जनरलाइज इसमें कितने जितने भी टर्म्स लेंगे उसमें सारे लिनियर कॉम्बिनेशन को डिवाइड्स करेंगे. अब हम लोग सी पार्ट पे जा रहे हैं. ये कह रहा है थर्ड पार्ट क्या कह रहा है? इफ a divides b and a divides c, implies a divides bx plus cy for any integer x and for any integer x and y. Now we are going to proof of this theorem. I mean say this part. A divides b implies there exists x belongs to z such that b is equal to ax. Similarly, there exists y belongs to z such that c is equal to a y. As a divides b, as a divides c. Consider bx plus cy. Bx plus cy is equal to, we put the values of b from above, like b is equal to ax into x. I mean ax square plus ay square. Now we take the common part a is equal to x square. We take here we change the values like x dash and y dash because here both are going to equal. So we remove this, we change the value of x dash and y dash. We erase this part. Now b is bx plus cy. But the value of b is equal to ax dash x plus ay dash y. We take the common value a is equal to x dash x plus y dash y. Since x dash x, y dash and y, both all these elements belongs to set of integers. So their product and addition also belongs to integer. Say m is equal to m and m belongs to set of integers. This is equal to am. By the definition, this implies a divides bx plus cy for any integer x and y. Now this part also. Now fourth part is fourth part, if A divides B and B divides A implies A is equal to plus minus B. Fourth part. If A divides B and B divides A implies A is equal to plus minus B. Proof. As A divides B implies there exists X belongs to Z such that B is equal to AX and there exists Y belongs to Z such that A is equal to BY. Since B divides A, we put the value of here we put the value of B and A is equal to AXY. This implies A is equal to AXY. Compare on both sides. This implies xi is equal to xy is equal to 1. Here xy belongs to set of integers. Then the possible value of x and y is plus 1 and minus 1 minus 1. So the possible values of x, y are only 1 and minus. So the value of v is equal to plus minus a by equation 1 या 2. B is equal to plus minus a. Now the fifth part is A divides B and both A and B are greater than 0 implies A is less than or equal to B. A is less than or equal to B. Fifth part is if A divides B where A is greater than 0 and B is greater than 0, this implies A is less than or equal to B. Proof. Since A divides B implies by the definition of divisibility there exists M belongs to set of integers such that B is equal to AM. case first, like we put the value of m is equal to 1, m is equal to 1, this implies a is equal to b. When m is greater than 1, if m is greater than 1, this implies am is greater than a. This implies b is greater than m. Third, if m is less than a, if m is less than 1, if m is less than 1, then the the given conditions fails, because if m is less than 1, then either a is negative or b is negative. So this fails the condition, fails the fails the given condition. So we can't consider the third case for given condition. So by first case 1 and case 2, this implies a is less than or equal to b. अब ये पार्ट भी प्रूफ हो गया. नाउ अब हम लोग जाएंगे लास्ट पार्ट के तरफ. लास्ट पार्ट क्या कह रहा है? इफ m is not equal to 0 and a divides b implies and is implied by ma divides mb. ma divides mb. 6 पार्ट क्या कह रहा है? So if a divides b and a divides b and sorry and m is non-zero, then if and only if, I mean implies and implied by ma divides mb. We prove the forward part. We firstly prove the forward part. If a divides b, this implies there exists m belongs to set of integers such that b is equal to am. Sorry, we choose another integers. Like x belongs to z such that b is equal to x. Multiply by m on both sides, then we get bm is equal to axm. Since bm, x all are integers, so we interchange this. mb is equal to max. Hence, by the definition, ma divides mb. Now converse part. Converse part. If ma divides mb, where m is non-zero, तो हमें क्लेम करना है a divides b. Since ma divides b, since ma divides mb, by the definition, there exists x belongs to z such that MB is equal to MAX. Since M is non-zero, so we divide M on both sides. Then we get B is equal to AX. Hence, by the definition, A divides B. Now, all parties going to be good. Thank you.